For generations, air superiority has been the backbone of American military power. From the jet age to stealth, each leap in aircraft design reshaped warfare. Today, behind closed hangars and under strict classification, the U.S. Air Force is pursuing what many call the next great leap, the Next Generation Air Dominance Program, or NGAD. More than just a new fighter, NGAD is a system of systems, a manned core fighter working with autonomous wingmen, advanced sensors, adaptive propulsion, cyber and electronic warfare packages, and an AI-driven decision layer. Official spokespeople have been careful with words, but scattered confirmations and controlled leaks have convinced analysts something concrete is taking flight. The question that haunts defense planners and rivals alike is simple. If NGAD achieves its goals, how will battlefield dynamics change when a single platform can see farther, decide faster, and coordinate strikes through a network of unmanned support? Over the next half hour, we'll unpack what NGAD is meant to be, why the Air Force pursued it, how it reportedly works, the technical and ethical barriers it must overcome, and what its arrival would mean for allies and adversaries. The NGAD program arose from strategic necessity. In recent years, potential adversaries have made extraordinary investments in stealthy fighters, long-range missiles, airborne sensors, anti-access capabilities, and space-enabled reconnaissance. The arithmetic that sustained U.S. air dominance for decades, forward bases, air refueling, tactical depth, is under pressure. The Air Force concluded that incremental upgrades to existing fleets would not be sufficient. Instead, it needed a fundamentally new approach. NGAD is a doctrinal answer, an aircraft designed from the outset to operate in the densest, most contested airspace, to survive by blending physical stealth with active electronic deception, and an architecture that offloads risk to lower-cost, expendable unmanned systems. More than replacing the F-22, NGAD seeks to future-proof air superiority through modularity, upgradability, and an emphasis on networks rather than single-platform performance. In short, NGAD is as much a strategic concept, how to organize and sustain air power in a networked age, as it is an airframe. A defining difference between NGAD and past programs is the family of systems mindset. Rather than a lone aircraft competing aircraft for aircraft, NGAD envisions a lead-manned platform embedded in a constellation of autonomous assets. These include loyal wingmen drones that fly ahead into the highest risk zones, sensor-laden UAVs that extend detection ranges, and possibly uncrewed missile truck platforms that carry large volumes of weapons while keeping the core fighter stealthy. The architecture also weaves in satellites, airborne early warning nodes, naval sensors, and ground networks, so that the manned fighter functions like a mobile command node. This distributed approach offers tactical flexibility. The pilot can marshal drones to create deception, to swarm and saturate defenses, or to create multi-axis attack options that overwhelm traditional intercept solutions. The family of systems concept reframes cost and attrition calculus too. Expensive manned platforms are preserved while lower-cost unmanned systems accept risk. Stealth remains central, but NGAD's notion of low observability goes beyond shaping and coatings. Designers aim for multispectral signature management that reduces radar, infrared, and electronic emissions, while also employing active deception. The airframe reportedly uses blended surfaces and internal bays to avoid external stores, but it is the ability to change signature postures, electronically and materially, that could set NGAD apart. Equally crucial is modularity. NGAD is being engineered to accept frequent upgrades to sensors, processors, and weapon payloads without a complete redesign. This allows the platform to adapt to new threats and mission needs across decades. A recognition that software and sensor advances will outpace any single hardware baseline. Finally, maintenance and sustainment were built into the design philosophy. Low observable materials that can be repaired in the field, modular components to minimize depot time, and logistics systems that keep squadrons airborne with higher readiness rates. No capability remains unchallenged. Adversaries will invest in countermeasures. Longer-range sensors, low-frequency radars better at spotting stealth, directed energy weapons, and new forms of electronic warfare. They will develop tactics to exploit communication dependencies between manned aircraft and unmanned wingmen, as well as more robust anti-air weapons and decoys. Consequently, NGAD's design philosophy emphasizes adaptability. Upgrades can be fielded via software, new sensor packages swapped into modular bays, and tactics revised in response to observed adversary counters. The program is as much about maintaining an adaptive posture as about fielding a singularly superior aircraft. The integration of autonomous systems raises important ethical and legal questions. When unmanned wingmen conduct kinetic actions, who is responsible for decisions made in complex, ambiguous environments? How do commanders ensure proportionality and discrimination when AI systems are interpreting data? The Air Force has insisted on human authority in lethal engagements, but automation levels complicate command chains. Operational rules of engagement, training standards, and legal frameworks will need to evolve to address the expanded role of autonomous systems in frontline combat. Transparent doctrine, careful verification of AI behavior, and international dialogue on norms will all be necessary to manage risk. If NGAD reaches operational maturity, it will reshape alliance calculations. Allies benefit from an American capability that can project air dominance farther and with lower vulnerability to peer defenses, enhancing collective deterrence. For partner nations, NGAD will also trigger investment decisions. Should they pursue complementary sensors, build integrated basing options, or acquire their own advanced platforms? Conversely, rivals will be forced to rescope defense spending toward counters and to consider asymmetric approaches that complicate NGAD operations. The strategic consequence is a renewed arms competition in sensors, autonomy, electronic warfare, and long-range strike, where the premium is placed on integration and resilience, rather than raw airframe counts. Predicting timelines for classified programs is imprecise, but several indicators help watchers assess progress. Public contract awards, prototype sightings, evidence of engine testing, and doctrinal publications that reference manned-unmanned teaming. Analysts widely expect prototype testing in the 2020s, with initial fielding of paired manned-unmanned units in the early to mid-2030s as technologies mature. The first visible signs to the public will likely be incremental. New doctrine, flight trials announced in sanitized press releases, or glimpses of companion drones in exercises. Those steps will mark the transition from secret testbed to operational capability and will prompt both excitement among proponents and concern among competitors. NGAD is neither just an airplane nor purely a technology project. It is a statement about how the US intends to maintain an edge in an era of contested, networked warfare by integrating stealth, adaptive propulsion, modular open architecture design, AI-assisted decision-making, and unmanned teaming. NGAD aims to keep American air power effective where simpler solutions will fail. If the program succeeds, it will extend deterrence, complicate adversary planning, and redefine how air campaigns are waged. If it struggles, the lessons learned will still accelerate advances in propulsion, autonomy, and sensor fusion across the force. Either way, NGAD is a central piece of the next chapter in military aviation, a chapter written in sensors, code, and tested on ranges the public seldom sees. If this deep dive into NGAD sparked your curiosity, don't miss what comes next. Subscribe to the channel for more long-form documentaries on emerging military technology, hit the bell to get notified when new episodes drop, and leave a comment telling us which program you want us to unpack next. An engine deep dive, a scenario simulation, or a comparison with competitor platforms like China's rumored 6th-gen projects. Give the video a like if you found it useful, and share it with friends who follow defense and technology. The skies of tomorrow are being shaped now, and we'll bring you the story as it unfolds.